Hello everyone, we are from Group 5 Biomedical Engineering Practice KIB3005 University Malaya. We are going to present our project proposal titled Pediatric Hospital Bed Design. Our group members consist of me, Asia, Amirah Zahra, Muhammad Shamil Fikri, and Muhammad Yusuf Aidit. Enjoy our presentation.
Hello and good day to all. My name is Muhammad Yusuf Aidit bin Zulkifli and I'm from Group 5. And today we'll talk about the clinical issue in UMMC regarding the pediatric hospital bed. Pediatric hospital beds are designed specifically for children, considering their size, safety and comfort. These beds often include features like side rails, adjustable height, and tilting capabilities. Despite these features, there are significant safety concerns. During a visit to UMMC, it was found that the bed design has flaws and needs some improvement. For example, there have been some instances where children manage to climb out of the beds, leading to additional medical care and delayed discharges. In severe cases, a child may sustain a head injury due to the bed's height being so tall. There are also cases where children's heads get stuck between the bed's rail due to their straight design and large gaps. Also, despite attentive care from nurses, some children manage to evade surveillance and attempt to leave the bed, leading to potential falls or similar incidents. Lastly, these incidents could be prevented by improving the bed design and enhancing the efficiency of the surveillance system. Next, by analyzing the clinical issue of pediatric hospital beds that occur in UMMC, we hypothesized that the changing some parts of the design and adding some electronic functions to the bed can overcome some of the concern regarding the patient safety. For instance, a tilted side rail design could make it more difficult for pediatric patients to climb over the rails, thereby reducing the risk of falls. Furthermore, a pressure sensor and alarm system can be installed to the pediatric beds as a means to inform the staff in charge about the climbing attempts made by the pediatric patients, thereby reducing the risk of fall and increasing the surveillance effectiveness. And lastly, the safety of the bed can be further improved by lowering the height of the bed. This is due to hypothetically lowering the height of the bed can reduce the severity of injuries due to fall damage that may happen if the patient manages to overcome the side rail. To test this hypothesis, we will make 3 experiments to test the capabilities.
Hello, my name is Amirah Zahra binti Ahmad Sharibi, matrix number U21021108, and today I will be explaining about the first experiment that we like to propose, which is heat entrapment risk of tilted rails in pediatric hospital bed design. So bed rails are used to keep people safe, but sometimes they can be risky. So people have gotten stuck or hurt in the spaces around bed rails. Our experiment looked at specific area in the bed system where most entrapment incidents happen based on advice from the FDA and UMMC. So we think that with tilted rails are safer than those with straight vertical rails. This is because straight rail can match up too perfectly with a child head movement, making it more likely to get stuck. Tilted rail, on the other hand, disrupt this and should make it less likely for a child head to get trapped. For this experiment, we have 2 main objectives to achieve, which are to determine if bed with tilted rails are safer for infant head than bed with vertical rail, and assess whether incorporating tilted rail into pediatric hospital bed is a viable and practical idea. So for the methodology, we start by designing tilted rail with computer software and then 3D print them. These rails are attached securely to a bed frame, and we do tests to see if a child head could get stuck, measuring the gaps between the rails, and we repeat the test with different size baby doll head to get a good look at how it works in different situations. Lastly, for the expected outcome of this experiment, we're hoping to see a big drop in the risk of a child getting stuck with deteriorate. But we also know there might be a similar risk or even new one we didn't think about. So this is why we are doing this experiment, to find out and make things safer.
Hello, my name is Asya binti Muhammad Ashraf, matrix number 1720435, and today I will be explaining about the second experiment, which is comparative analysis of pediatric fall risk, assessing the impact of bed height on risk of injuries. In hospitals, kids are at higher risk of accidental injuries, and falls are a big concern. The height of hospital beds plays a role, and making adjustment can make things safer. When beds are higher, the risk of serious injuries from falls goes up. A study in the Journal of Pediatric Nursing even showed that for every 10 cm increase in bed height, the chance of fall-related injuries goes up by 22%. To keep things safe, the American Academy of Pediatrics suggests keeping pediatric beds as low as possible when they are not being used. Our hypothesis is having pediatric hospital beds lower is way better for preventing serious injuries if a kid happens to fall compared to beds that are taller. For this experiment, the objective is to assess whether a pediatric hospital bed with a lower height significantly decreases the likelihood of severe injuries in the event of a fall in comparison to a bed with a greater height. For the methodology, we start by putting the accelerometer on both the infant dummies, one for lower bed and one for higher bed. Then, we initiate the fall simulation by releasing the dummies. We use high-speed cameras to record the entire fall, capturing details of the downward motion and impact. We also gather data from the accelerometers to calculate relevant injury metrics, such as head injury criterion. We repeat the experiment 3 times to ensure reliable statistical analysis. For the possible outcome, we expect that if the beds for kids are lower, it could mean a big drop in the force of impact and the head injury criterion if they happen to fall. This expectation is because the fall isn't as far, so when they hit the ground, the speed is lower and the force is less. By studying high-speed videos of falls, we might see variations in how kids land and move. Falling from lower beds might show less movement of the head and body, lowering the chances of hitting things or landing in ways that could make injuries worse. Thank you.
Assalamualaikum and greetings everyone. I'm Shamil and today I'd like to delve into our third experiment focusing on the pressure sensor based fall prevention system for pediatric beds. This experiment addresses a crucial concern, namely the susceptibility of the pediatric patients to falls, as emphasized by the Clinical Accident Commission's Pediatric Fall and Entrapment Prevention and Management Guideline in 2020. And this guideline highlights the inherent risk associated with the climbing behaviors, particularly in children aged from 18 months to 3 years. And despite the implementation of the bed range, these guidelines underscores persistent challenges, emphasizing the constant need for the supervision within this age group. And this is also a concern that we have heard firsthand from the nurses at PPUM who shared their experiences with children displaying a tendency to climb over and contribute to the urgency of finding an effective solution. So to address this pressing issue, we introduced an innovative and technologically advanced solution, which is the embedded sensors along the bed rails coupled with an alert system. And this is not only aligns with the established guidelines, but also introduces a proactive and also efficient technological intervention. So our hypothesis revolves around the implementation of an Arduino circuit featuring primarily a pressure sensor and a buzzer that are strategically embedded along the bed rails. And the primary function of this pressure sensor is to detect the substantial pressure, which is a clear indicator of a child attempting to climb. And upon detecting such pressure, the system is designed to trigger a piezo buzzer, which effectively serving as an alarm. And this alarm serves as to alert users to the climbing behaviors and also act as a preventive measure to mitigate the potential risk of falls. So our first objective is to rigorously evaluate how well our pressure sensor functions in preventing the pediatric falls from pediatric beds. And the second objective focuses on the system's ability to promptly notify medical professionals and provide the necessary assistance in preventing the fall from happening. Let's move on to the methodology. So basically for this experiment, we'll be using Arduino Uno to build up our system, and we'll be also using Tinkercad software to simulate the circuit. And so the first thing that we need to do is to, of course, gather all the necessary materials for the circuit construction, which is Arduino Uno, for sensor, connecting wires, resistor, and a piezo buzzer. And next, we need to connect the positive and negative terminals of the piezo buzzer to digital pin 3 and ground respectively on the Arduino board using jumper wires. And basically all of the connections we can see on the screen here based on the sketch that stated here. And then the next step is to set up the force sensor, which is connect one terminal to analog pin A0 with a 1 kilo ohm resistor, and then link it to the ground, and then connect the other terminal to the 5 volt power supply on the Arduino. And lastly, we need to upload the code sketch to the Arduino using the Arduino IDE software. So basically, when the force exceeds the set threshold, which is in this case 200, which is raw analog reading from the Arduino, and approximately 1.76 newtons. And once this threshold is met, the piezo buzzer will be activated and signaling an audible alert. So last but not least, our expected outcome. So our experiment envisions a successful validation of a pressure sensor based fault prevention system for pediatric bags, and we anticipate the system's buzzer to activate when applied pressure surpasses a predefined threshold and providing an immediate alert. And this outcome could mark a significant advancement in pediatric bed safety, enhancing the protective measures against falls. And with this system in place, the nurse in charge doesn't have to maintain a constant 24/7 vigilance, as the alarm can alert even when the nurse is away from the bed. And this is not only aids in fall prevention but also ease the burden on the nursing staff, allowing for a more efficient and responsive healthcare environment. So that's all from me. Thank you.
And that concludes our group presentation. Thank you for lending your ears and hope you gain some insight. Give this a thumb up if you enjoyed it. Bye bye.